Welcome to 201A Part 2. Now we covered the first three objectives. Now in this video we're going to cover Objective 4 and Objective 5. So first, Objective 4, Scientific Notation. Scientific notation is a simpler way to show numbers. Instead of having a number with lots and lots of zeros behind it or lots and lots of zeros in front of it if it becomes less than 1, we can use scientific notation. What this is we use a base number, which is going to be one whole number and decimal points behind it, and then we're going to multiply it with the number 10 with an exponent. So this is base 10 with an exponent. What this means is that whatever the 10 with the exponent is, that exponent represents how many times that we need to move the decimal point. That exponent also is a representation of which way to move the decimal point. So if I have 6.72 times 10 to the power of 9, that means I have to move the decimal point 9 times. And since it is a positive exponent, that means this number is going to be much bigger than 6.72. So that should tell me that I need to make this number bigger by moving the decimal point 9 times to the right. So this becomes 6,720,000,000. That's 6.72 times 10 to the power of 9. When we look at the same number that has a negative exponent, the rules are still the same. We're still going to move the decimal point 9 places, but that negative represents a number that's much smaller than 1. So we want to make sure that we move that decimal point to the left this time. What we end up with is if we take that decimal point, move it 9 times to the left, we get 0.00000000672. That's a really hard number to say, which is why it's important for us to use scientific notation. It simplifies things so much for us. When we start talking about capacitors, we start talking about microfarads and nanofarads and picofarads. Well, these are also ways to express scientific notation. And we need to know that a microfarad is 10 to negative 6, for example. So by understanding scientific notation and understanding that the exponent is representation of how many decimal points you have to move and whether that exponent is positive or negative, and we'll tell you whether or not to move to the left or the right. That's all you really need to know about scientific notation. The most important thing to remember is to think about what that number should be looking like. If it is 10 to the negative 9, we know that number is going to be less than 1, and that should give us a good hint about which way to move that decimal point. With scientific notation, we move the decimal by the number of the exponent. Numbers greater than 1 have a positive exponent. Numbers less than 1 have a negative exponent. So these are your clues. How many do I move? Which way do I move it? And once we represent numbers and we want to convert numbers from whole numbers to scientific notations, this also tells us. So if we look at the number 1,000, I need to move the decimal point over 1, 2, 3 spots to get behind that 1. And we always have one full number and then a decimal point for scientific notation. So 1,000 is equal to 1 times 10 to the power of 3. When I look at 0.001, I have to move the decimal point 1, 2, 3. So it's on the right side of that 1. Therefore, it's 1 times 10 to the negative 3. Since my number is less than 1, it's going to have a negative exponent, and I have to move that decimal place 3 places. So let's look at converting this number. Now this number is greater than 1, so therefore it's going to have a positive power of 10. In order to get that decimal point from between the 5 and the 3, and move it over so it's just past the 6, so it's going to be 6.75, I have to move it 2 places. So that means my exponent is going to be 2. And since it's larger than 1, it's going to be a positive 2. So this turns into 6.753 times 10 to the power of 2. That's the scientific notation for this number. With this number, since this number is less than 1, we know that the exponent is going to be negative exponent. And once again, that decimal place has to be to the right of the first number. So I'm going to need to move that one over one location. Since it's going over 1 and it is a number that's less than 1, we're going to have 6.35 times 10 to the power of negative 1. And that is the scientific notation for 0.635. When it comes to putting scientific notation into your calculator, most calculators are the same. However, depending on your brand, it might be slightly different. So be aware of that. If you happen to have the Sharp 520 calculator that we recommended you for the course, we do have what is called the EXP button, which is just above the 7 on your calculator. In order to show the multiplication factor of our scientific notation, we would go 1 exp 9, which would be the same as 10 to the power of 9. I'm also going to let you know that if we use the YX button, which is one row up and one button over from the EXP button, then we put this in to be 10 YX 9, which is still be the same as 10 to the power of 9. So we can use these two different buttons to represent the multiplication factor. And of course, with the scientific notation, that just gives us what the multiplication is going to be for that unit. If we understand scientific notation, we can move on to looking at what SI prefixes are. An SI prefix is just an easier way for us to represent a multiplication factor or to represent a scientific notation. With SI prefixes, we always start with a base, and our base could be volts or amps or meters or liters or even elephants if we really wanted them to. What the SI prefixes represent is the multiplication of that base unit. For example, we all know what a kilometer is. A kilometer equals 1,000 meters. That's because the kilo has multiplication of 1,000. If I had 5 kilometers, that would equal 5,000 meters, meters being my base unit. So the SI prefixes represent both the multiplier as well as the scientific notation. So 5 kilometers would be 5 times 10 to the power 3 meters. The other thing we need to know about SI prefixes is that each one of them has their own separate symbol to represent what they mean, such as giga and mega would be G's and M's, kilos or K's, centis or C's, millis or M's. One that you might not be aware of is the micro, which is a funny looking U. So as long as we understand what the symbols for each SI prefixes are, and we remember what the multiplication factor for each prefix, that'll go a long way for us to understanding how to deal with the prefixes as we find them. A simple way to help us with base units and SI prefixes is to create a ladder diagram out of this. So if I have a base unit of 1, every step down would be adding another 0 to it every time. So 1 base unit is equal to 10 decibase units. So a 1 meter equals 10 decimeters equals 100 centimeters, which equals 1,000 millimeters. If I were to go the other way with my base unit and go up the scale instead, 1 meter is equal to 0.1 decameters, 0.01 hectometers, or 0.0001 kilometers. So this is an easy way for me to take whatever my base unit is and figure out how many of the other ones I have. And as long as you remember that each step should represent another power of 10, then it's going to be easy for you to use this for conversion. I can also go the other way. If I start with a base unit of 1,000, that represents 1 kilo, right? So 1,000 meters represents 1 kilometer. That also means that 1 kilometer represents 10 hectometers, 100 decameters, 1,000 meters, 10,000 decimeters, 100,000 centimeters, and 1 million millimeters. So if I need to convert from a kilo down to a milli, I can use this step diagram in order to do that. Every step represents a power of 10, and that means we're going to add one more 0 to it every single time we go down. That is the end of both scientific notation and SI prefixes. Make sure you return to Blackboard. I do have a worksheet for part 2 there for you. Do the knowledge check and then continue on to part 3, which is going to be on objective number 6.